So in our last unit, you learned about how different atoms come together to make molecules and how two or more nonmetals can come together to make molecules that have covalent bonds. So let's just do a quick example. If I had two fluorine atoms, fluorine is a nonmetal. I start by drawing the Lewis structure. So I know that fluorine has 7 valence electrons. So I'm going to put 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4, 5, 6, 7 valence electrons around each fluorine atom. You learned in the last unit about a rule called the octet rule that says that an atom is stable if it either has a full octet with 8 valence electrons or an empty octet with 0 valence electrons. So if each fluorine atom has 7, then each of them needs to gain 1 more. So what's going to happen is that fluorine and fluorine are going to share valence electrons. So this fluorine atom is going to sort of donate one of its electrons to the middle, and this fluorine atom is going to donate one of its electrons to the middle, and that'll form a shared pair of valence electrons, which we call a covalent bond. And this is what the final molecule looks like. 2 fluorine atoms, each with 3 lone pairs, and then 1 shared pair of electrons between the 2 of them, and that's called a covalent bond. And this molecule satisfies the octet rule because each fluorine has a total 8 valence electrons around it. Now these 2 fluorine atoms are locked together. They're locked together through this covalent bond. And that's going to be one of the big differences when I show you ionic compounds, that ionic compounds are not locked together. So let's do an example. So if covalent compounds are made with 2 or more nonmetals, ionic compounds are made up with metals and nonmetals together. Now, when we get to more complicated and advanced problems, we'll see ionic compounds that have maybe more than 1 metal but only 1 nonmetal, or 1 metal and more than 1 nonmetal. But for now, we're going to start really simple and just show an example of an ionic compound that's made of 1 metal and 1 nonmetal. So in case you've forgotten how to tell if an element is metal or nonmetal, you can look at the periodic table, and you'll see this staircase drawn out on the right-hand side. Everything to the top and right of the periodic table is considered a nonmetal. And that actually includes hydrogen as well, which is over on the top left-hand corner. All of the other elements are actually considered metals. So everything in this region of the periodic table, as well as down here. So for my example, I'm going to choose 1 nonmetal, which is going to be chlorine, and 1 metal, which is going to be sodium. Right? And just like as if I was drawing a covalent compound, I'm going to start by looking for the number of valence electrons around each. Sodium is in the first group, so it's going to have 1 valence electron. Chlorine is in the 7th group over to the right, so it's going to have 1, 2, 3, 4, 5, 6, 7 valence electrons. Now let's go back to what we said about the octet rule. The octet rule tells us that an atom either needs 8 valence electrons or 0 valence electrons to be stable. Now in this case, sodium only has 1. So it's going to be much easier for sodium to lose 1 valence electron and have 0 than to try and gain a full 7 electrons to have 8 around the outside. So we know that sodium's going to want to lose 1 electron. We know that sodium's going to want to lose 1 electron. Now chlorine behaves just like fluorine. It's got 7 valence electrons, which means it's going to be much easier for it to gain 1 electron and have a full octet than to try and lose all 7 and have an empty outer shell. So let's revisit this. Sodium wants to lose an electron, chlorine wants to gain an electron. It should be fairly obvious. Sodium is simply going to donate its electron to chlorine. It's going to give it up completely because it would rather be empty than have 1. So what you're left with is sodium, which looks like this, with an empty outer shell, and chlorine, which looks like this, with a full outer shell. But we're not done. And this is where ionic compounds become a little bit more complicated than covalent compounds. Unlike in a covalent compound where the two atoms are sharing an electron, we have one atom that's completely lost an electron and one atom that's completely gained an electron. And that's going to throw off the charges. And let me show you what I mean by that. Chlorine has an atomic number of 17, which means that normally chlorine has 17 protons and 17 electrons. But chlorine just gained one electron, right? This electron used to belong to sodium. So now what that means is that chlorine actually has 18 electrons. And the reason that that's important is that the charges don't balance anymore. Chlorine has 17 positive charges, but it actually has 18 negative charges. So we actually say that this chlorine is negatively charged. And so when we draw chlorine with the 8 valence electrons around it now, we have to put a little negative sign up top to show that this isn't just chlorine, this is chlorine negative, because it's gained an extra negative charge. Now at the other end of things, sodium has an atomic number of 11, which means that normally sodium has 11 protons and 11 electrons. But again, that has changed. Sodium donated one of its electrons to chlorine, which means that now sodium actually has 10 electrons. So it's sort of the opposite of chlorine. Chlorine gained a negative charge, sodium lost a negative charge, which means, again, the charges don't balance. Sodium has 11 protons, but only 10 electrons, which means that it has, overall, a positive charge. So we put a little positive sign next to the sodium. And so what we're left with is a sodium atom with an empty shell and a positive charge, and a chlorine atom with a full shell and a negative charge. And these are called ions. So that's the big vocab word for today. Ions are simply charged atoms. And by charged atoms, it means they either have a negative charge like chlorine or a positive charge like sodium. And where do these charges come from? They come from one atom giving up an electron and the other atom gaining an electron. And that changes the total number of electrons in the atom, which throws off that balance between protons and electrons. Another big difference between ionic compounds and covalent compounds is that in a covalent compound, these two fluorine atoms are completely locked together, right? They're sharing those electrons, so they can't drift too far away. You'll see over here, there's nothing that actually locks the sodium ion and the chlorine ion together, right? They're going to end up staying relatively nearby because positive and negative attract, so they're attracted to each other. But unlike the two fluorines, they're not actually locked together. So there's one last thing you need to know for today, and that's the names for the two different types of ions. So there are cations, and cations are ions that have a positive charge. So for example, Na positive, and then there are anions. And anions have a negative charge, for example, chlorine.